Dear students, today we are going to see a new lesson, structure of the atom. In the previous chapter, you have seen Dalton atomic theory. Am I right? Well, what it states that? Yes, atom is the basic structural unit for matter. It cannot be divided. But at the end of 19th century, there was a question mark in front of the scientist. What about the structure of the atom? Whether there is any subatomic particles present in it. So, they went for many experiments to bring out the structure of the atom. The first subatomic particle, electron, was identified by the scientist J.J. Thomson. Later on, proton was identified by the scientist Goldstein. What about its properties? Let us see it now. If you comb your hair with a comb it for some time and bring into a piece of paper, you can see paper is attracted to the comb. Here, are you able to see? Okay. Why it happens? Here, comb gets charged. That means some particles are inside the atom. When two things are rubbed with each other, they are charged. Where does these charges come from? The scientists brought out there are some subatomic particles present in the atom. As I told you, the first one, electron, was done by the scientist J.J. Thomson, and Goldstein discovered proton present inside the atom and it is positively charged. Okay, you know very well. Proton is denoted by letter small p and electron is by E. Proton is positively charged and electron is negatively charged. Where does it occupy? They also proved that protons are accumulated at the center of the atom and electrons are spread out here and there. To prove or to bring out the correct structure of the atom, many scientists proposed their models. The first model was done by the scientist J.J. Thomson. Now you could have understood. Dalton atomic theory statement is false for atom cannot be divided. Here, atom can be divided because there are some atomic particles are present inside it. Okay, what it states that, let us see now. J.J. Thomson atomic model is just like, or it is similar to the structure of a Christmas pudding or Christmas or any cake and watermelon. Have you seen watermelon? Yes. It is a favorite fruit in the summer season. During this season, it is available also. It is watery. Water content is more. Atom is like a sphere. The positive charges is present everywhere and electrons are accumulated or spreaded or embedded here and there, just like, have you seen dry fruits in the cake? It is embedded here and there. Like that, electrons are present in the positive sphere of the atom. And also we can compare it watermelon. Watermelon, the edible part, that red color part is positive sphere and the seeds are spreaded here and there. They are like electrons. Hope you understood the structure of J.J. Thomson model. Okay. He proposed 2 points from his models. What it is? Consists of positively charged sphere and electrons are embedded in it. That is the first point. And another point also, he stated that the positive particles, that means protons, are equal magnitude with the electrons. That means the positive and negative charges are equal in magnitude. That magnitude means amount. That's why the whole atom is neutral. Okay, these are the 2 points he brought out from his model. Scientists were not satisfied with this model. Again, many scientists have done many experiments to bring out the correct atomic structure of the atom. Let us see it. The another model. It was done by the scientist Rutherford. The scientist named Ernest Rutherford brought out a model. It is called alpha ray scattering experiment. In his experiment, he selected gold foil and alpha ray. Why he selected gold foil? Because we can make thin sheet from gold, so it may have more number of atoms. And the reason for selecting alpha ray is it is positively charged and also it is heavier, it possesses more energy. As per the model of J.J. Thomson, positive charge sphere is in atom. So, Rutherford also thought that when he passed alpha ray to the thin sheet of gold, he expected alpha ray particle will come back because alpha particle is heavier and also possesses more energy than protons. But he noticed different result. What was that? Let us see it now. Look at this diagram. This circle indicates the atom of gold and alpha ray is allowed to fall on gold foil. That means on the atom of the gold. He noticed that some of the alpha particles deflected back and some move without any deflection and some shows small deflection. From this observation, he brought out his postulates. What are those things? You know very well, alpha ray particle is positively charged. Here, it is getting deflected back. It shows that alpha particles falls on the positively charged particles. It is getting deflected because you know very well, same charges repel. So he said that nucleus, inside the nucleus protons are kept. That means at the center of the atom protons are present. And here there is a small deflection in alpha ray. It shows that there is a space inside the atom. And why it is deflected towards the end of the circle? It shows that electrons are present in the outermost of the atom, and in this case it moves as such without any deviation because there is a space inside the atom. So he brought out his postulates or his points. Our alpha ray scattering experiment states that protons are present at the center of the atom, electrons are present at the outer part of the atom. The size of nucleus is small as compared to the size of the atom. That's why it is pointed as a small point. Okay, these are the points he brought out. We can compare for you to easy understanding. For example, close your eyes and stand in front of a fence you could have seen, and throw stones to the fence. If the stone touches the fencing wire, it will come back. Am I right? Some stones will pass through between two fencing wires. That means there is a space. That's why here they are moving as such without any deviation. And if the stone touches the end of the fencing wire, maybe there will be a small deflection in its movement. It will pass away. Otherwise, it will move to the other side of the fencing. Hope you understood the structure of the alpha ray scattering experiment and also Rutherford model. Then one of the drawback in his model, that is, you know very well, when any object are in movement, it will be accelerated. If it is accelerated, it will emit energy. If it is continuously emitting energy, what will happen? That means it loses its energy and it will fall down. He was not able to explain the reason for the presence of electrons in the outer part of the atom.